All right, good morning to everybody. For all of you here early, special treat, Bambi's here. Here's Bambi, my 14-year-old gal. She wants to get out of here as soon as possible, so I'll let her out. Go ahead, see you later, Bambi. All right, anyways, today we're getting on with 8.3. This is converting or dealing with complex numbers, putting them into polar form. And so here's most of the notes. I don't have the idea or the notes about the roots up here. So when we get to those problems, then I'll make sure to kind of put those notes up and talk through that a little bit. But first off, we have complex number. If you remember back to Math 126, is the form A plus BI. So we have this concept called a modulus. That's just the square root, square both of those numbers. And then to convert from complex to polar form. So honestly, that's going to be the most important topic from this section, is converting from complex into polar form, and then multiplying or dividing them. So to go from complex to polar, we need to have a value of r and our value of theta. And r is just the modulus, which is just Pythagorean theorem, which is all this stuff we've been doing all semester long, square root of a squared plus b squared. So that gives us our value for r. And then tangent of theta is b over a. And the key is that whichever quadrant our complex number begins in, we have to use that theta that ends up in the same quadrant. Again, just like we've been doing all semester long. One thing I want to point out here, I don't think I mentioned in the videos, but when you're entering in a number in polar form, you always want theta to be between 0 and 2 pi. So if we're if we're multiplying or dividing polar numbers, if this addition or this subtraction does not put us between 0 and 2 pi, we want to convert the number, either take 2 pi out of it, or if it's a negative number, convert it to a positive number. That's the ideal form that we want it in. If we're multiplying polar numbers, we multiply the r values, we add the thetas. If we're dividing and we divide the r values, we subtract the thetas. And then lastly is our de Moivre's theorem. So this is if we have some complex number raised to an exponent. So then it's just r to that value, and then we multiply the theta by the value of n. So again, I know the roots aren't up here. I'll talk about that a little bit when we get to those problems that you guys want to see. But before I move on from this, any questions you guys have about any of these concepts? No questions? Everybody here this morning? Looks like we got 9 of you so far. All right, well, I'm going to go ahead and erase this end. And again, remember, if you ever do have a question, just type a couple exclamation points, hit enter. That way I know you're typing a question before I erase anything or move on. All right, so all right, let's start with number 14. Actually, kind of going to jump around a little bit. So we want to write in polar form the complex number given by negative 4i. So our complex form is what? A plus bi. So in this case, the a is just 0. So if we want to put in a 0 there, so when we start doing our calculations, it makes sense. And then let's think about where this point is going to end up on the complex plane. So a is essentially our x, left and right, and b is our up and down. So for this one, we're moving 0 units left and right, and then 4 units down, which means I'm right down here at the bottom of the axis system. So to convert this, first thing I need is my r, which is the square root of a, which is 0 squared plus -4 squared. So this is square root of 0 plus -4 squared is positive 16. So my r is just equal to 4. And then theta, so tangent of theta is b, which is -4 over a, which is 0. So -4 over 0, this is undefined. So where on my unit circle is tangent of theta undefined? That's when theta is either pi over 2 or 3 pi over 2. And again, I'm always going to have these two possibilities, and it has to end up where? It has to end up down here at the bottom of the axis system. So that means the theta I need is going to be 3 pi over 2. So therefore, my z in polar form is r, which is 4, cosine of 3 pi over 2 plus I sine of 3 pi over 2. So that's how we convert a complex number into a polar number. Figure out our r, figure out theta. We're going to have two possibilities. We have to pick the one where the point is to begin with, and then you just write it in that form there. So any questions on that problem? All right. So are you guys able to, nobody said anything this morning here, so you guys are able to comment and stuff, right? Anybody want to say that you're here or whatever, just so I know you guys can comment? Not yet, too early. So one thing too, I asked you guys for some feedback, and okay. Good morning, everybody. Just making sure that you guys can communicate. So I did mention how I sort of hate this, like just talking at you guys for 75 minutes. But some of the, okay, good morning, everybody. Glad you guys are here. But the majority of the feedback, or actually all the feedback, said that you guys like this format. And so we'll keep it for now. It doesn't mean that we can't change it later if we start running into complications, but I guess for now we'll leave it this way. That way too, if you have to go back and watch it, then you'll have that ability. So, all right, so let's jump back to number 5. So this is a Domov's theorem problem. And we want to figure out square root of 2 over 2 plus square root of 2 over 2i to the 12th power. So for Domov's theorem, we're going to need our r, we're going to need our theta, and we're going to need our n. So this guy here, this is our n. Our r is still the same. A squared root 2 over 2 squared plus root 2 over 2 squared. So this becomes what? 2 over 4 plus 2 over 4, which is 4 over 4, which is 1. Square root of 1 is just 1. So our r is equal to 1 in this case. And then theta, tangent of theta is b root 2 over 2 divided by a root 2 over 2. This is just equal to 1. So where is tangent of theta equal to 1? That's either pi over 4 or in quadrant 3, 5 pi over 4. So which one do we use? Well, we have to go back to this guy here. So this is A is positive, B is positive, so that puts us where? Up in quadrant 1. So I need to use pi over 4 as my value of theta. So now I have my r, I have theta, and I have n. So by Domov's theorem, z to the 12th in this case is going to be r 1 to the 12th power cosine of n 12 times theta pi over 4 plus I sine of 12 times pi over 4. So simple. So any questions so far? Are you guys okay? Actually, let me jump over to WebAssign. Let's see. Just want to make sure I put the answer because one thing you need to gotta log in. Hold on, sorry. Which number is this? Number 5. Okay. So one thing I want to point out about this and is how it wants the answer formatted. So we had some issues with this on exam 2, answers not being formatted correctly. Same thing here with WebAssign. So you guys need to make sure that you're formatting your answers correctly. So to that point, I spoke to, I mean, I got 12. So I guess hopefully everybody else watches the video later, hears this information. So I talked with the coordinator for 127 this morning, and we talked about the final exam and what the format is going to be. And I think as of now, we're leaning towards doing the final exam as an exam with questions from WebAssign. So you will log into WebAssign and you'll take the exam there. So it'll essentially be like the assessments that you guys have been doing. A couple reasons. One is it gives us a little bit more freedom with the questions. And the second is you're then familiar with how the answers should be formatted, or hopefully you're familiar with that. So we're going to work on it a little bit later today and kind of start coming to a conclusion. So if we decide that's what's going to be done, then your guys' exam 3 will actually be a WebAssign exam. It'll be whatever, similar to your assessments, but it'll be with questions, from WebAssign rather than through Canvas like you did before. So part of it, again, is the formatting. How do they want the answer formatted? They want it in A plus BI form, in complex form. So I need to simplify this thing down. So 1 to the 12th is just 1. So then I get cosine. Well, 12 cancels with 4 and gives me 3. So 3 pi plus I sine of 3 pi. So then I need to simplify this. So cosine of 3 pi. Well, 3 pi, if you remember, puts us over on the left. And cosine of 3 pi then is what? It's -1. And then sine of 3 pi is what? Well, that's equal to 0. So this whole term is equal to 0. So your answer for this one would simply be -1. So does that make sense? So we used Dumont's theorem to get to here. The problem states put your answer in A plus BI form. So we need to get rid of all the pi's and all the trig functions. And it just leaves us with -1. Okay, question. So hold on here for a second. Can you go over that one more time? Sure. So if, let me erase this here. If this said leave your answer in polar form, we would have had that guy there. And technically, if we simplified it, we want our answer, if you remember before, we want the pi to be between 0 and 2 pi. So if I subtract 2 pi out of both of these, this is cosine of pi plus I sine of pi. So if this said write your answer in polar form, this would have been the answer that you put in. But WebAssign specifies write your answer in A plus BI form. So it doesn't want any trig functions or pi or any of that. So I need to convert both of these to numbers. Well, cosine of pi is what? That's -1. And sine of pi, so that's over here on the left, that's 0. So this piece is 0, so the whole thing is 0. So therefore, this is -1 plus 0, so just -1, because it specifies it wants the answer A plus BI form, so that gives it the value -1. If it said write your answer in polar form, then we could have left it as this, cosine of pi plus I sine of pi. But because it's saying A plus BI form, we have to keep going further on that. Does that make sense, or still some confusion? Or any other questions from anybody else besides Chase? Okay, yep. All right, so let's go on to number 6. So now that you guys see how to do that, let me have you try this one. So you have 1 minus I to the 7th power. Yes, okay. So let me double check again if this is A plus BI form. Oh, wait, oh yeah, 6. Yeah, so write in A plus BI form. Okay, so go ahead and try this one. If you get stuck, you want to try to type in your question or something, that's fine. Otherwise, if you guys give it a shot, type in done once you're done. Or I guess if you already have it done, you can type done, or if you're not sure what to do, you can type done. That way I know at least you guys are sort of done processing through, and then I'll work it here on the board for you. Okay, good. Okay. Okay. All right. 1, 2, 3, 8. 8 of the 11. So I'll give you guys another minute or so here. Everybody have a good weekend. Any of you guys watch Casa de Papel? They released a new episode on Friday. One of my favorite shows. So I was up to like 1 in the morning on Friday or Saturday morning watching that stupid thing. Okay, Stephanie. All right, so it looks like most of you guys are done. So let's process this through. Again, our n is 7. So r is square root of 1 squared plus another 1 squared. So square root of 2. Oh, boring. You should have watched Casa de Papel then. That would have made it exciting. And then our theta. So tangent of theta is b, -1 over a, which is 1. So -1. Where is theta equal to -1? That's either 3 pi over 4 or 7 pi over 4. So which quadrant are we in? Well, A is positive, B is negative, so it's down here in quadrant 4, meaning we need 7 pi over 4 as our answer, as our theta. So if I write it, okay, that's a good one too. If I write this in polar form, it's what? So z to the 7th is square root of 2 to the 7th power times cosine of 7 times 7 pi over 4 plus I sine of 7 times 7 pi over 4. So this guy here, so square root of 2 to the 7th power means what? It means square root of 2 times square root of 2 7 times, right? One, two, three, four, five, six, 7. So square root of 2 times square root of 2, that's 2. Square root of 2 times square root of 2, that's 2. That's 2. So what do I have? 2 times 2 is 4, times 2 is 8, times square root of 2. So this piece here is really 8 square root of 2. So does that make sense to everybody? Or any questions on that before I erase it and get rid of the mess here? All right, so then in here, I have 7 times 7 pi over 4. So that's what? This is like 49 pi over 4. And I want this answer to be between 0 and 2 pi. So if I divide this, 49 divided by 4 is what? It's 12. Well, it's 12, which is 48, plus 1 pi over 4. So 12 pi puts me where? Back at the start. So this whole thing, 49 pi over 4, is really the same as pi over 4. So I can rewrite this whole big mess that I have here as 8 root 2 times cosine of pi over 4 plus I sine of pi over 4. I multiply the 7 here, gives me 49. Convert that to a mixed number is 12 pi plus 1 over. 12 pi puts me back at the start, plus pi over 4 is the equivalent of pi over 4. So this is the answer in polar form, but again, it wants the answer in a plus bi form. So cosine of pi over 4 is what? It's root 2 over 2. Same over here, root 2 over 2. So if I have 8 times root 2 over 2, so this is 8 root 2 times square root of 2 over 2. So root 2 times root 2 is 2 divided by 2. So these guys all cancel out. So this part is just equal to 8. And the same thing is going to happen here. We're always going to end up with the same number. So this is 8 plus 8. And don't forget the I that you had here. So your final answer should have been 8 plus 8i. Any questions on that one? That one's pretty tricky. No questions? Everybody's okay on that? All right. So now let's get into our roots. So first, let me write the notes up about the roots. So if we have some polar number, r cosine theta plus I sine of theta. And if it has n roots, then we get the following formula. We use this W, which is omega. So omega k is now r to the 1 over n power cosine of theta plus 2 pi k over n plus I sine of theta plus 2 pi k over n. And then our k goes from 0, 1, 2, etc. up to n minus 1. So if I have 3 roots, I'd have k is 0, 1, 2. If I have 5 roots, 0, 1, 2, 3, 4. However many roots I have, I go up to n minus 1. So this is my formula. So it's still kind of the same information. What's my r? What's my theta? How many roots do I have? And then it's a matter of plugging in the formula and keep changing my values for k. So let's look at a problem here. So number 4, is it 2 roots? Let me confirm. Yes, all right. So we're looking for the square roots. Square is 2, so the 2 roots of 4 root 3 plus 4i. So our n, the number of roots, is 2. We need r. We figured out the same way. So 4 root 3 squared plus 4 squared. So 4 root 3, so square root of 3 squared is 3. 4 squared is 16. 16 times 3 is 48. And then 4 squared is 16. So this is square root of 64, which is 8. So our r is equal to 8. So far, so good. If you guys need me to stop, make sure you type in the exclamation point. And then for our theta, so tangent of theta is b over a, 4 over 4 root 3. 4's cancel out. This is 1 over root 3, which when we rationalize it is square root of 3 over 3. So we're in which quadrant? A is positive, B is positive. This is in quadrant 1. So where in quadrant 1 is tangent of theta equal to square root of 3 over 3? That's when theta is pi over 6. So I have my r, I have my theta, I have my n. So the formula then, so omega k, the different roots, is r, which is 8, to the 1/2 power. If you guys remember back to 126, anything to the 1/2 power is the square root. So the square root of 8. And then cosine theta, pi over 6, plus 2 pi k over n, which is 2. Plus I sine pi over 6, 2 pi k, 2 pi k over n, which is 2. So let me stop here. So this is our root formula. It's not our actual answers, because we have to pick k is 0 and k is 1 and calculate what do these values turn into. So before I do that, though, any questions of how we get to this point? And I will say this is probably the worst topic to have to do remotely. Not being able to be there in class and have you guys ask questions for this topic is not good. The good news is this isn't going to be on an exam. I wouldn't put one of these. Okay, Chase, go ahead and type your question. I'm not going to put one of these root questions on the exam. There's no need for it. How do we determine what our n is? So it's the number of roots. So this problem said find the square roots of whatever. So square is 2. If it said find the cube roots, that would be 3. If it said find the 4 roots, that would be 4. If it said find the 10 roots of whatever, n would be 10. So the tricky ones are 2 and 3. If it's square root, n is 2. If it's cube root, n is 3. Because this problem said find the square roots of this guy, that means our n is 2. Any other questions before we move on here? Yep. All right. So now we have to figure this out. So when k is 0, so I plug in 0 for these. So this really just becomes, this guy's going to cancel out at 0. So it's pi over 6 over 2. Pi divided by 6 divided by 2 is like pi over 6 times a half. So that's pi over 12. So k0 is square root of 8 cosine of pi over 12 plus I sine of pi over 12. That's your first answer. Questions on that? So all I did was plug in k is 0, so that piece disappears, so we just have pi over 6 over 2. For k is 1. So when k is 1, the numerator here becomes pi over 6 plus 2 pi. Well, 2 pi is like 12 pi over 6, which is 13 pi over 6. So when k is equal to 1, the numerator becomes 13 pi over 6. I have to divide this whole thing by 2 again, which is multiplied by a half. So this is really 13 pi over 12. So this becomes square root of 8 cosine of 13 pi over 12 plus I sine of 13 pi over 12. So that should be your 2 answers, I believe. Let me double check that's what they want. Yep. So that's it. So you're leaving it in polar form. Leave theta in radians. So that's it. These are you could simplify square root of 8 if you want, but I'm assuming it'll take it anyways as that. So those are your 2 roots for this guy. So any questions on that? And then is this the one that has graphing as well? Yeah. So it asks you to graph it as well. So if you're graphing these points, pi over 12 is what? That's just barely into the first quadrant. And 13 pi over 12 is where? That's barely into the third quadrant. So you're just picking the graph that has 1 point in quadrant 1 and 1 point in quadrant 3. So it should look something like that. So any questions on this before I erase this guy? Okay. So the next one, I'll kind of get you started on it and then let you guys work it through. So it is number 7. We have z to the 4th plus 1 is equal to 0. And we need to find the roots for this guy. So first of all, if I move the 1 over, z to the 4th is equal to -1. And to put this in complex form, I'm going to put plus 0i. So when we try to figure this thing out later, we know what our values of a and b are. So I'm trying to find the roots of z. So how many roots do I have? 4. So it's similar to like if I have z squared is whatever, 3. So to solve this, I get what? I have to take the square root to get z by itself. So same idea here. This problem is super confusing because it's not really sure, like, well, how am I supposed to find the roots of this? So assuming that it said, okay, like similar to the last problem, your complex number. So think of this problem like this. Given this complex number, what are the four roots of this guy? That's really what the original problem is saying. It's written like this, but what it means is, what are the four roots of this? So go ahead and try this. Find your R, find your theta. Your n is what? Your n is 4. So we want 4 roots. So in this case, our n is 4. So then go ahead, try to find your value for r, find your value for theta, and then use that root formula that we had. And again, if you have questions, feel free to type them in. I'll try to talk it out or write it on the board for you. So. Type done so I know you're done. Okay, good, good. All right, you guys about another minute or so here. So I forgot to give you guys your attendance problem. And since this is the last one you guys asked about, we'll make this the attendance. So when I work this one, you want to put this in your ticket out the door notebook, or if you already have it done, if you just want to copy it over. Sorry about that. I just remember that as I was sitting there. So this will be the attendance problem. So again, the attendance problem, that'll be in the ticket out the door notebook. So at the end of the semester, as I'm reviewing your guys' ticket out the door notebooks, I'll be looking for these attendance problems as well. And if you have all the attendance problem, then you get the full grade for the attendance. I think it's like 5 or 10% attendance / pop quizzes. So easy enough. Just put this in your notebook and you get those points. So, all right, so let's work through this. So I'm going to erase all this stuff and kind of clean it up so we have enough room here, because this problem, I believe, takes a little bit of space. So we want the fourth root, -1 plus 0i. So first thing, our r, square root of a, -1 squared, plus b, 0 squared, is square root of 1, which is just 1. That makes life easy for us. And then theta. So tangent of theta is b, 0 over a, -1, which is 0. So where is tangent of theta equal to 0? That's either 0 or pi. And this complex number is where? -1 and up 0. So that means that in this case, our theta is equal to pi. So r is 1, theta is pi, n is 4. Any questions on that before I move on? All right, so omega k is our r, which is 1 to the 1/4 power, which is still just 1. So really, it's just going to be our theta pi plus 2 pi k over n, which is 4, cosine, plus I sine of pi plus 2 pi k over 4. So now we got to do k is 0, k is 1, k is 2, k is 3. That's where we stop. So for k is 0, again, this piece drops off. So I get cosine of pi over 4 plus I sine of pi over 4. And if I remember correctly, this wants it in, yep, so it wants it in, well, that's weird. Huh. So it says express theta in radians, but then looks like it has it in a plus bi form. So if we simplify this further, so did anybody enter this as the answer? Does it take this as the answer, or do you need it in a plus bi form? So I'll let you guys type it in, but so cosine of pi over 4 is what? Root 2 over 2 plus root 2 over 2 times I. When k is 1. So when k is 1, this becomes pi plus 2 pi, which is 3 pi over 4. So cosine of 3 pi over 4 plus I sine of 3 pi over 4. So cosine of 3 pi over 4, negative root 2 over 2. Sine of 3 pi over 4, positive root 2 over 2. I typed it in as a plus bi form. Okay. That's what it shows as my answer there, but then in the instructions it said enter your answer theta in radians. So I don't know why it says that, but it wants this answer. All right, k is 2. So when k is 2, 2 times 2 pi is 4. 4 plus 1 is 5, so you can see what's happening here. This is 5 pi over 4. And the next one, when k is 3, is 7 pi over 4. It's just hitting all the pi over 4 values. So cosine of 5 pi over 4, negative root 2 over 2. Sine of 5 pi over 4, negative root 2 over 2. And then last but not least, in quadrant 4, positive root 2 over 2 minus root 2 over 2i. So these would be the 4 answers that you have for problem number 7. So any questions on that one? Even though the start of this one was a little trickier, it ends up being a little easier with the math because we're not dealing with all those pi over 6 divided by 2, et cetera, et cetera. It just gives us our radian measures. Any questions on that guy? All right. So let me give you, so again, put this one in your ticket out the door notebook for your attendance problem for today. And then I'll give you your ticket out the door. All right, so your ticket out the door today. Just one problem, 3 parts. So if Z1 is equal to negative 1 plus I, and Z2 is 1 minus root 3I, find the following. What's Z1 in polar form? What's Z2 in polar form? And then C, part 3, what's Z1 times Z2? So go ahead and try those 3. Again, I'll give you guys a few minutes when you get done. Well, I'll give you more than a few minutes. I'll give you as much time as you need. Once you finish, just type done. And once a handful of you have it done, then I'll put the answer on the board. And I can go through if you're not sure how to do it. I can kind of work through it as well. We have plenty of time. We still have, 25 minutes, so it shouldn't take that long. Go ahead and try that. If you do have questions, go ahead and ask those as well. That's fine. So I'll give you guys a heads up too for 8.4. So in 8.4, we're going to be doing parametric equations. And part of it is taking parameters and converting it to rectangular equations. And so just as a hint for you guys, if you want to, I know the problems that usually give people trouble, it's ones that have trig functions in it. And so what you're going to do is try to use formulas that you know that have, so let's say that X has sine in it and Y has cosine in it. What formula do we know that has sine and cosine, our holy grail? So use that formula and try to make the substitutions into the formula that way to convert it from rectangular to parametric equations into rectangular equations. So just kind of keep that in mind as you're doing those problems for 8.4. If you don't get it, that's fine. I'm sure we'll be working them on Thursday anyhow, but just so if you want to try to tackle it yourself, that's what you would have to do. So again, once you guys get done with this one, just type done. And after a few of you have it done, then I can give you the answers. The rest of you can keep working. If you get stuck, you have questions, I can help you out. Hey, Kyla. Alright, so since a few of you guys are finishing up, let me post the answers here. Again, if you're still working it, keep working it. That's fine. Not going to kick you off the system here. I'll wait around till you guys have it done or as far as you can. So Z1 in polar form should be square root of 2 times cosine of 3 pi over 4 plus I sine of 3 pi over 4. Z2 should be 2 times cosine 5 pi over 3 plus I sine of 5 pi over 3. And then our product Z1 times Z2 is 2 times square root of 2 times cosine, and we want our theta to be between 0 and 2 pi. So cosine of 5 pi over 12 plus I sine of 5 pi over 12. So when you add these two, you end up with 29 pi over 12. 29 divided by 12 is bigger than 2. So take 2 pi out of it. Get it so your theta is between 0 and 2 pi. That would be your final answer. So if you guys are done and you have it, have the correct answer, then I will see you guys on Thursday. If not, feel free to keep working it. Once you're done, just let me know you're done. And as people start dropping off, I'll end the live stream. But otherwise, you guys are good to go. Have a good night, good day, good night, good day tomorrow. And we'll see you guys on Thursday morning. If you have a question on any of these answers, go ahead and ask it. Could you explain Z1 times Z2? Sure. So once I have Z1, Z2, Z1 times Z2 is you multiply the R's. So 2 times square root of 2. And then I add the thetas. So 3 pi over 4 plus 5 pi over 3. And I sine is the same thing, 3 pi over 4 plus 5 pi over 3. I mean, like turning them into polar form. Oh, how to get, so these two, how to get these two into polar form? If that's your question, so we have to find our R. So R1 is like we were doing earlier, square root of 1 plus 1, so square root of 2. Then tangent of theta is B over A, 1 over negative 1. Where is that negative? It's in quadrant 2 or 4. And this guy is in quadrant 2. This guy is in quadrant 4. So for this one in quadrant 2, our theta is 3 pi over 4. And then we do the same thing for Z2. How do we find our R? Square this, square that, add them together. That's 4. Square root of 4 is 2. And then tangent of theta, B over A. So where is that? That's at 5 pi over 3. That makes sense, Chase, or still more questions? Okay. Okay. Any other questions from anybody, or are you guys still working? You need more time? Just let me know. So it looks like there's still about 7 of you on. Are you guys still working it? 6 now? Starting to drop off. You guys still need me to hang on? I'll hold on. Otherwise, I'll end the live stream here. So just let me know. All right. So, okay. So it looks like you guys are wrapping it up. I will see you guys on Thursday. If you do have a question, you can post it on that discussion thread, or else just ask about it Thursday before we get going. I can answer any other questions you guys have. Otherwise, have a good day, and we'll see you guys on Thursday.